All right. Now, you might have asked yourself, the inquisitive students that you are, what comes next after multiplication? Well, division, right? But division's a little messy in the modular system, so we're not going to worry about that. But what is a natural extension of the multiplication system is the exponent system, exponentiation. Exponentiation is just an abbreviated process of multiplication, just like how multiplication is an abbreviated process of addition. Now, then our question is, well, let's see if exponentiation holds up under modular arithmetic. So, let a1 be congruent to a2 mod m, and n is n is a natural number. Show that a1 squared is congruent to a2 squared mod m. So that's a basic version. Basic example to show exponentiation might work when we square something. And then after that, we want to show that it works for any exponent. So show that a1 to the nth power, it could be to the millionth power, it could be to the billionth power. Let's show that that's congruent to a2 to the nth power as well. So let's start out with always just what we know. And what we know is that a1 is congruent to a2 mod m. And let us begin part A. Now, well, something that we had just learned about is that multiplication holds under the modular system. So, for instance, the multiplication property goes like this. If a1 is congruent to... I should actually use different letters here. So I'm going to say x1 is congruent to x2 mod m. And y1 is congruent to y2 mod m. Then their products are congruent as well. So x1 times y1 is congruent to x2 times y2 mod m. So if these are true, then we get this. Well, I know that a1 is congruent to a2 mod m. So what that means is, like, if we want to think about it in a really obtuse way, you could say that I know this is true, and I know that this is true, even though it's going to be, I'm writing the exact same thing. Mod m. Then I know that the product of a1 times a1 is congruent to the product of a2 times a2 mod m. This is a pretty obtuse way to write it, but I think it demonstrates naturally how it would lead to that, right? And of course, anything multiplied by itself is just itself squared. So a1 squared is going to be congruent to, well, a2 times a2 is a2 squared mod m. Hence, completing part A. So, how about part B? How can we show to the nth power? Is there such a way? Well, we have established at least that let's use the previous information to help us solve this. So a1 squared is congruent to a2 squared mod m. And I know also that a1 is congruent to a2 mod m. So again, their products are going to be congruent as well. For instance, if I multiply this by an a1 and I multiply this side by a2, the products are going to be the same as well. Hence, a1 times a1 squared is a1 to the third power. And that's going to be congruent to a2 to the third power mod m. Okay? And I can do this again. Multiply by a1 and multiply by a2 on the other side. The congruence still holds. And I get a1 to the fourth power is congruent to a2 to the fourth power mod m. And this process is just going to repeat itself until we have a1 to the n minus 1th power, which would be congruent to a2 to the n minus 1th power mod m. We can just do this process infinitely, achieving higher exponents indefinitely, until at last we arrive at a1 to the n minus 1 and a2 to the n minus 1. Now, I'm just going to do exactly the same thing. Multiply by a1 on the left and a2 on the right. Well, let's write that. We can do a little bit better than that. So that's a2 and, well, a2 to the n minus 1. Now, if we don't know exponent rules, if you have x to the nth power times x to the mth power, that's always just x to the n plus m. That's what we've been doing this whole time. Like, this is to the first power. So first power plus second power gives us the third power. First power plus third power gives us the fourth power, so on and so on. So in this case, this is to the first power. This is to the first power. Anything raised to the first power is just the value itself. And if I add those two values together, we have 1 plus n minus 1, which is just equal to n. 1 minus 1 cancels out. So this part becomes a1 to the nth power, which is going to be congruent to a2 to the nth power mod m, which is the result we wanted. Even if that last part was a little confusing, hopefully that process of infinitely multiplying by a1 and a2 on both sides, I mean a1 on the left and a2 on the right, hopefully that process of infinitely repeating that makes logical sense on why it shows us, or why it demonstrates that we will always have that a1 to the nth power is equal to a2 to the nth power. It's just a natural conclusion or natural result from our multiplication property. So this establishes that If we have a1 congruent to a2 mod m, then a1 to the nth power is congruent to a2 to the nth power mod m, which means we can raise the value to any exponent we want and it will always maintain its congruence. And we'll see exactly how we can utilize this. And this one definitely makes life easy in the next couple problems.